This morning, we're going to talk about Microsoft-based solutions running on Lenovo. And I get the really fun job of actually talking about the hardware parts of the software story. However, we are going to do a bit of background. So, let's think about the challenges we have in today's software-defined data center. Meeting the challenges of the modern heterogeneous workloads we all deal with. These different types of applications, different types of demands in terms of virtualization, networking, and compute. Doing that at a scale and a performance that meets our needs. Whatever size of business we're dealing with, we have to deal with this dynamic scale, dynamic size, and the ability to flex in line with business change and need. And critically, hitting a budget, or hitting the price point, as I like to think about it. Absolutely key in the modern IT infrastructure. So, as many of you know, I am a great believer in the software-defined data center. This idea of using industry-standard hardware with industry-standard software to drive up scale, drive down cost, and deliver increased scale. And I'm a great believer in doing this through 100% virtualization and 100% automation on a unified hardware and software layer. Here's the key thing which is a little bit different about the type of talks I often give here. This stuff only works if you use vendor hardware that works with validated drivers and validated software, because this stuff tends to not work if those components aren't there. Now, let's talk a little bit about why we do software-defined data centers. Many of us are used to this world of buying a storage area network, and buying very large switching infrastructure, and paying for lots of extra services, volume replication, quality of service on the switch, FEXs at the end of their switching fabric, etc., etc., etc. A lot of us are very used to having either physical hardware or virtualization at limited scale when it comes to delivering our applications. In the software-defined data center world, we are moving that virtualization stack and that management of virtualization into software. Quality of service, availability, delivery of capabilities, all delivered from software. So, I think we kind of all understand the power and the capability of the software-defined data center. And as you know, I am a great believer in this philosophy. And Server 2016 is the ideal platform to make that platform a reality. However, believe it or not, this is a quote that my father said to me when I was about 7, actually. I remember it vividly. I was sitting at home, and he'd come home with this thing called a laptop. A laptop at that point had a tiny little green screen that flipped up and came in the size of a backpack, about 4 times the size of the thing at the back of me. But he said to me, he said, Philip, what you have to remember is the power of software is delivered through the capability of the hardware. Without the hardware, the software achieves absolutely nothing. And one of the interesting things about this session today is we'll talk about putting the tin into the software-defined data center story. So, let's think about this a little bit more. The Server 2016 hardware topology, broadly speaking, looks like this. I know this diagram is focused towards storage spaces direct, but the reason that is the case is because in Server 2016, we're primarily talking about a hyperconverged scenario. And if we're going to do hyperconverged, we're probably going to do storage spaces direct, which means we're going to go up to 16 nodes. So, we're talking 3 to 16 nodes using industry standard hardware. We are then talking about using dual socket. This is a really important thing. You want to always be having 2 physical CPUs in your servers. These servers have got to do lots and lots of workloads. You need those dual physical clocks. You need at least 128 gig of RAM or more, right? The days of 32 gig or 64 gig of RAM in your servers are gone. Please don't do it anymore. You need at least 10 gig or higher networking, preferably RDMA. We'll talk some more about RDMA in a while. We need at least 2 high-performance caching drives, something like SSD or NVMe, at least. We need at least 4 capacity drives, HDD or SSD, in every single server. Think about that for a second, because there's 2 interesting things there. On one hand, this seems like quite high requirements, on one hand. On the other hand, this is very standard hardware we can now buy in standard equipment. So actually what we're really saying here is that this level of performance and capability we can all purchase from fantastic vendor hardware. And of course, the last thing you need in the Storage Spaces Direct and Server 2016 world is a standard SAS or SATA host bus adapter. These RAID cards, thank you very much indeed. No iSCSI, no fiber channel, standard host HPAs. So there's a fairly standard hardware topology. Now, who has spent their lives reading the hardware compatibility list? Come on, wake up. Come on, I know it's Thursday. Now, as you all know, the hardware compatibility list has been around for a long, long, long time. The interesting thing about Server 2016 is that the hardware, it's not about a hardware compatibility list any longer. It's about a truly integrated hardware and software story between Microsoft and the vendor. That's a fundamental leap forward, because rather than going, well, they're on the hardware compatibility list, and that bit's on the hardware compatibility list, and that bit's on the hardware compatibility list, and if I plug them all together, I might get a toaster. You now have the situation where you can select from your hardware vendors integrated solutions that will work. That is a fundamental shift going forwards. So, I've spoken a bit about the software-defined data center. I've spoken a bit about the fact that the hardware specifications and the role of the hardware vendor has changed. Now let's talk about some of the capabilities that are key when it comes to hardware capabilities in Server 2016. Now, a lot of you who have been listening to my sessions this week will recognize some of these slides. So we're going to talk about Storage Spaces Direct. We are going to talk about software-defined networking. We're going to talk about shielded VM. We're also going to talk about remote desktop services, which is the one we haven't spoken about at all this week. Each of these key capabilities would not be possible without the ability of hardware. So let's dig into these slightly more. Storage Spaces Direct. As you know, many of us today, when we build our storage fabrics, what we're after is highly available scale-out storage. We want a system that redefines performance and scale. And I love saying this, we want a system that's going to make the SAN obsolete. Now, you'll be familiar with a model like this, what is known as the shared SAS model. And this diagram was, when I originally drew it, was all about scale-out file server in 2012 and 2012 R2. But actually, if you look at this diagram, it applies just as much to traditional SAN technologies, where we have this idea of servers, or nodes, and they're each connected to some form of JBOD, just a bunch of disks. And we play wire spaghetti. And we have lots of SAS cables going all over the place. And we plug every single server into every single JBOD, and you hope it's all going to work. And by the way, in your SAN, it's exactly the same thing. It's just in a nice, pretty box. Now, in the Storage Spaces Direct world, we move into the situation where instead of having spaghetti between the servers, we have the servers connected to the disks directly. So one server to a set of disks mapping. And then we use the network. The network now becomes our system to go and keep those disks in sync. That commodity, that high-performance commodity network keeps our disks in sync. However, we can use that construct. And if anybody actually attended my session yesterday talking about Nano Server, you'll have seen actually I demonstrated Storage Spaces Direct using external JBODs in that session. However, the model most of us will be doing, especially with new hardware in this generation, is the disks inside the server. This is a fundamental way to think about storage. Because instead of thinking node or server, external storage, we are now thinking commodity standard servers with internal disk. Being able to build dynamically high performance, high capacity, scale out storage arrays. Think this through for a second. Standard hardware from Lenovo, using Windows Server 2016, delivering breakthrough performance and capacity. This just wasn't possible before. Fantastic movement forward in capability. So, that was Storage Spaces Direct. And as you know, there have been plenty of sessions on deep diving it. Let's now talk about networking and storage-defined networking. There are two things when it comes to networking. The first thing we need to think about is Storage Spaces Direct and many of the other systems inside of Server 2016 absolutely rely on networking. They don't work without it. So therefore, high-speed, reliable networking is critical. If you do not get your networking correct in Server 2016, everything else will fail. I cannot say that equivocally enough. Now, The first thing to talk about is RDMA versus non-RDMA. Who here is working with RDMA today? 2 people. Right. For those of you who are not familiar with RDMA, the simple way to think about RDMA is that the network traffic workload is offloaded to a chip on the network card. Think about that for a second. Instead of using the CPU to compute the, I've sent a piece of data, you've got a piece of data, I've sent that piece of data, you've got a piece of data, I'm getting bored talking to myself, so are you getting bored talking to yourself. All of that workload is moved onto a chip on the card. What does that mean? It means RDMA performance is significantly higher than non-RDMA performance. So, overall CPU utilization is lower. Overall latency on the network is significantly lower. Let's look at some numbers. Look at this test configuration. This is a comparatively small test, right? It's only doing 4 nodes with 40 virtual machines per node. Let's look at the difference in overall throughput between RDMA and non-RDMA. Without RDMA, 320,000, which by the way is quite good. Look at it with RDMA, 540,000, 69% better performance. Yes, IOPS. Yes, I'm so sorry. Yes, actually, no. So the question is that metric IOPS? Yes, forgive me. This test is a performance test based on a comparatively small 4-node configuration running 40 VMs per node being set to generate internal load to simulate IOPS. Forgive me, a question, sir. Go for it. I think the question was, with more VMs, would you get significantly better performance? Yes, indeed. So this is a very good question. So the real issue here is that this was not about overall stress testing the system. It was about showing the difference in performance RDMA versus non-RDMA. Does that make sense? Yes. But I think your question brings up a wider point. Because you have RDMA, you have lower CPU overhead, and therefore you'd have capacity for more VMs in your overall system anyway. Okay. As some of you will have seen in some of my other sessions this week, I have demonstrated systems running on Lenovo hardware. In fact, I did it yesterday, and I would recommend you watch the video, running in excess of 3.3 million IOPS, and a real-time throughput of just under 14 gigabytes a second, off only 8 nodes. By the way, that's very good performance. If you think about that for a second, I'd like to see many systems do 14 gigabytes a second. But it's made possible because of RDMA. I think that's a very, very, very key point. Now, let's now talk about tenant isolation, the software side of the networking story. Tenant isolation is very important for service providers, but it's also now very, very important for the enterprise because it's about putting your separate business units into isolated components or isolated containers so that, let's say, company A and company B cannot see each other, but they can use and build their networks in complete isolation as if they are their own networks. Now, tenant isolation, or software-defined networking as it's commonly known, is an encapsulation-based technology. There are 2 main standards here. NVGRE is the one Microsoft supported. The rest of the industry supports VXLAN, which Microsoft also supports in Server 2016. I stress, this is a software-based solution. This is not VLANs. This is encapsulation that allows you to build dynamic virtualized networks over the top of your core fabric. However, let's look at this in more detail. Imagine the following picture. You have this virtualization layer with physical servers at the bottom. I now have red virtual machine. Red virtual machine can only talk to red virtual network. Please notice this is Lenovo red. Matches their shirts at the front. We then have blue virtual machine that can only talk to blue network. Remember, blue network and red network can share the same IP range but cannot see each other at all. True network isolation. Very, very, very powerful technology, which if you're not using it today, you may well consider using going forwards, and come down and see us this afternoon, we'll talk about it. However, software-defined networking is an encapsulation-based technology. What it actually does under the covers is it wraps every single networking packet that is on the virtual network with an external wrapper that allows it to communicate on the underlying physical network. That is very, very, very CPU intensive. Fortunately, the network card vendors have come to our rescue, and they support offload. And I have a gentleman in front who is yawning. It is only 10:15, sir. Please wake up. This is what happened, you see, in the morning. Now, forgive me. Fortunately, the network card vendors have provided hardware offload inside their network cards. This is absolutely critical in the software-defined networking world. And again, Lenovo, in all of their server configurations, their network cards that support RDMA also support hardware offload of software-defined networking encapsulation. Any questions on software networking as I have some time? Have I scared everyone that much? Clearly. Okay, let's keep going. As we move into planning for the Server 2016 era, many of you will have existing network topologies you already have built. You're probably running a combination of 10 and 1 gigabyte networks. You probably don't have the stuff you need to go and support Server 2016 properly. Your networks probably aren't up to the correct speed to support these 10 and 40 gig networks properly. You probably don't have the data center bridging support, or if you do, it's going to be very costly. I would highly recommend the following. Don't go, I'm going to put in a brand new networking infrastructure when I want to do my Server 2016 upgrade. It's not a good idea. I have worked with organizations that said, I know, I'm going to replace 5,000 ports as part of a Server 2016 deployment. Not a good idea. What I would highly recommend you do is put in dedicated switching fabrics for your Storage Spaces Direct and 2016 RDMA networks, and then have those uplink into wider infrastructure. I spent a lot of time working with Lenovo switches, and one of the things I rather like is how well they integrate with other switch vendors. So I can use my Lenovo hardware to build fantastic, isolated, dedicated storage fabric networks, and then have those very effectively uplink into my wider network topologies. It's been a very, very, very enjoyable story, actually, when I've done it. Now, let's talk about network topology design for a second. I suspect some of you are using the topology on the left, which is what I call the non-highly available SME scenario. Fine, absolutely fine. You want to go and use one switch, and you don't need high availability on the switches? Absolutely fine. No problem. The topology on the right is what I call the legacy enterprise model, where we have this idea of these two switches where you cross-link your cables, but the switches don't really function together. It's a model, hopefully, that is dying out, and I wouldn't recommend doing it. The model I highly recommend you use is the one in the middle, where you have highly available switches, but they are functioning as a single virtual integrated unit, with each of your servers connected into each server. This gives you both port redundancy and switch redundancy. Again, though, you're minimizing your costs and your investment on hardware and still gaining high availability. You'll notice the table at the bottom actually gives you the pros and cons over resiliency and network configuration options, whether or not and how many subnets it requires and what resiliency it supports. So you'll take that with us. Yes, sir. So far, sir. Question? Yeah. Right, so the question is, if you purchase Azure Stack, would you get the switching solution that looked like that? Yes. The integrated Lenovo MAS stack, and in fact, Greg is going to talk about this afternoon, it contains the highly available switching fabric as part of the bill of materials. And it is ready configured as part of the box. Yes, that is a very good question. Any other questions while we have the pause? Yes, sir. Oh, right. If you'd attended my session on Monday, I spoke about it. Okay. There are two common standards when it comes to RDMA. One is IWARP and one is RoCE. Okay. Primarily, RoCE is supported by an organization called Mellanox, and IWARP is supported by an organization called Chelsea. Both have pros and cons, but they're both very, very, very good. There are setup differences in the two interfaces and the protocols, and they do not mix with each other. Today, Lenovo is supporting a Mellanox implementation, which means that it's the RoCE standard, right? And that requires data center bridging on the switches, and they support 10 and 40 gig, and will support 100 gig going forwards. The IWARP standard, if you look at this in Chelsea, they have 10, 40, and 100 gig implementations as well. You know, It's worth noting they won't work together, those two standards, but they both use the same switch port standards. That's the way to think about it. Does that answer your question? Yes, sure. Any other questions? Actually, one more question on the iWalk versus Chelsea. If you have questions on those, I would highly recommend attending Don Stanwyck's session tomorrow afternoon, where he's going to talk about the very subject in great detail. Good, onwards. The subject I haven't got to talk about yet this week, and it's one of my favorite subjects, remote desktop services. Now, many of you probably know remote desktop services as this thing for logging into your servers and remotely supporting it. What a lot of you might not realize is that for many years now, remote desktop services have been able to do full remoting of audio, full remoting of video, full remoting of touch. Right? And Microsoft now has a very mature set of client apps that work on iOS, Android, Windows, etc. However, there is a wonderful technology that is in remote desktop services called virtual GPU. That technology, and if any of you attended my sessions in previous years, you'd have seen me show this, allows you to expose high-performance 3D graphics into your virtual machines. So you can do things like CAD/CAM activities, or you can do things like gaming. However, that technology had some fairly major limitations. For a start, it only supported the DirectX protocol. The other thing is, it only worked in Windows Client, which actually kind of made it not very easy to use in lots of scenarios. And the biggest problem is it didn't support the two technologies used by most of the graphics industry, OpenGL and OpenCL. So about 3 years ago, I said to the RDS engineering team, I'm going to get very grumpy if you don't support these standards. And because I look like an evil psychopathic thug, fortunately they listened to me. So I'm very pleased to say that they now support both OpenGL and OpenCL inside the virtual GPU. That's fantastic, because that means you can run things like those high-performance CAD and CAM applications, like CAD/CAM applications, that you couldn't traditionally run. That's really important, because it means that in virtualization on powerful hardware, you can run the applications that you used to spend $10,000 buying a workstation on, and you can spin them up when you need them. There's another really important change that happened with GPU. Windows now supports directly mapping a GPU into a virtual machine. So for those ultra high performance scenarios, you can directly expose GPUs into your virtual machines. That's very important, because for your developers and your people doing big data types of applications, because they now support the OpenCL standard, they can offload a lot of that math and that compute activity into that GPU directly inside of your VM. The last two changes that happened inside of remote desktop services was that all of these capabilities have now been lit up inside of Windows Server. So you're not now limited to Windows 10 client. You can now do all of these capabilities inside of Windows Server. That's even more important, especially for the service providers, because it means that you can now offer multi-tenant hosted VDI via Windows Server. Another anecdote here, if people didn't realize. Windows Server is built on top of what's called the same manifest as Windows 10 client. That's important because unlike previous versions, Windows Server has everything that client has in it from the point of view of the store and the user experience. That's a really important difference because it makes it a very, very, very good virtual desktop infrastructure client. Now, moving on. Shielded VM. As many of you know, my favorite subject. So, Shielded VM has been introduced for the first time in Server 2016 and redefines the approach we take to security. Shielded VM solves this problem. Who has any idea what that actually means? Ah, good, a couple of hands. Impressive. Right. I prefer saying it that way around. Fixes the Fabric admin has to trust your hoster problem. In other words, Shielded VM finally brings a situation where your Fabric admin supplying your core storage, network, and compute can deploy VMs that then your application managers can run knowing full well that the Fabric admin can't look at the virtual hard disk, modify the configuration, fiddle with it, steal it, or generally abuse it. They can, by the way, back it up, live migrate it, and they can turn it off. And by the way, if you ask, that's a bit weird, they can turn it off. If you think about it, the Fabric admin could have just pulled the power out the back of the server. So letting them turn it off is probably acceptable. Now, shielded VM is very interesting because it's based on some quite clever cryptographic technologies that effectively authenticates and authorizes the underlying hypervisor host and says, that host I trust to host these special shielded VMs. And then it allows a shielded VM to run it. And it has a number of those hosts that are defined as being acceptable for running shielded VMs. And the system will only allow a shielded VM to be on a host that is compatible for running shielded VMs. That takes advantage of what is called TPM. TPM2, in fact, right? And this is a piece of hardware technology that is built into the server equipment. So let's kind of talk about the hardware bits for a second. I touched on this before. I cannot stress enough that Server 2016 and the role of the hardware vendor has fundamentally changed. Microsoft is primarily only going to support validated original equipment manufacturer solutions. Homebrew solutions are not going to be supported by Microsoft. Yes, you can physically build them, but it is not going to be a supported path. And here's the other fundamental change. The solutions from the equipment manufacturers are going to include the hardware, the software, and the configuration story. For the first time, you are going to get a truly integrated experience from your hardware vendor, rather than this, we've sold you a bag of bits, and here's a license, and bye-bye, off you go, have some fun. It's a fundamentally different approach, and it really makes life simpler because Server 2016 is very, very complicated. And as a user, you have the situation where finally the hardware vendor will actually be delivering you a package which actually works out of the box. Fundamental change. So let's talk about those bits for a second. Storage spaces direct. These are the things you actually need in the box to make it work. First of all, you need a lovely disk-dense server that allows you to store lots of lots of hard disks inside of a server. The second thing you need is you really need a server that supports rear-facing hard disks. You might think, why? Why do I need that? I've still got to put a copy of Windows on this box. And if I use those nice disks at the front, I'm going to chew up my disk capacity. So you want to serve with a couple of disks at the back, stick Windows onto. You really want support for NVMe. As you know, in my sessions I gave earlier on this week, we talked about the performance of NVMe and how it really enhances the experience of storage spaces direct. You then need, raw SAS controllers that allow you just to expose all these disks as standard SAS. You don't want the RAID controllers in the way. You don't want backplates that emulate RAID and SAS. You want true SAS expanders. You need those high-performance, high-capacity local SAS drives. And lastly, you need support for those RDMA networking cards. And you need those all in-box from your hardware vendor in a validated scenario with drivers and firmware which actually work. Now, let's talk about software-defined networking. You need that VXLAN and that NVGRE offload. Without it, your performance is going to be appalling. When I say appalling, I mean more than about 10 VMs and your network card is your processor is going to collapse. In box, you need those capabilities. Oh, that's appalling to look at color-wise, isn't it? I'm so sorry. And lastly, we spoke about shielded VM. And we need this thing that's called the TPM chip. If you're not familiar, by the way, who has a Microsoft Surface laptop? Surface? Yeah, who's got Surfaces? So all of you have TPM chips. Yes? TPM2 is a server version of that technology. That's what TPM is. It's a hardware-based protection system. And the last thing is the advanced GPU acceleration. And in particular here, this is using onboard high-performance graphics cards in box, in server, right? So that you can expose all these fantastic graphics capabilities I spoke about. Now, in about 45 minutes' time, I'm going to be downstairs talking about some of the real-world deployments that I have done in partnership with Lenovo on some early adopter customers. And it's going to be 12:05 downstairs in Theatre 1. So please all come down there so I can yell at you some more. As part of that session, we're going to talk about 3 customers. SC Cal Factory, us, Accutech, and Kodak Alaris, all who have 3 very different requirements from Server 2016. But all who achieved it using Storage Spaces Direct on the Lenovo hardware. Very different scenarios, and we're going to talk about those. Later. Now, In a minute, I'm going to play a video of SC Cloud Factory. But what I'm first of all going to do is pause. Do we have any questions at this point? Go for it, sir. Right. Does the HS require 2.0 yourselves? No, it doesn't, but they do have to run on tin. So the question is, does the host guard require TPM2? No, it doesn't, but you've got to have the money on physical servers, and no, it cannot run on Nano. Is the other gotcha from that point of view. Any other questions, sir? Okay, in that case then, what I'm going to do is I'm going to run the video of SC Cloud Factory, and then once I finish that session, I am going to head downstairs, and I'll hand you over to Greg, who is now going to actually talk about the Lenovo implementation of a lot of the hardware I've spoken about here. So I shall run this video. Thank you very much indeed, everyone, and I shall see you downstairs in about 45 minutes. Thank you.
Hi everybody, my name is Jacob Schmidt. I'm the CEO of SE Cloud Factory. I want to welcome you all to Atlanta. Let me tell you a bit about SE Cloud Factory and the SE Group. SE Cloud Factory opened our business in 2014 with a special focus on infrastructure, hosting and cloud. The SE Group is more than 100 years old and one of Denmark's largest telco and energy companies. We are 1,500 employees and serving more than 400,000 customers in Denmark. In Cloud Factory, we have a special focus on virtual servers running in our data centers in Denmark. We provide a full virtual network, infrastructure, and connecting customers on-premise with Cloud Factory and bringing the complete hybrid to life with Azure and Office 365. We started back in 2014 with classic servers and traditional storage. But as time went along, we saw the trend from many customers bringing their entire infrastructure to Cloud Factory, literally lifting up their servers and migrating them to SE Cloud Factory one-to-one. Even though we built quite a big data center in the beginning, we saw that compute was way overrated, but the demands for storage and storage IOPS was exploding under us. About a year and a half ago, we started out in the software layer together with the Microsoft CAD and product teams in Redmond. On this journey, we picked up Intel and Lenovo to build the next generation hyper-converged data center to meet the demands from our customers. Mission accomplished. I tell you, we have more IOPS and this low latency that you have never seen. Let me tell you in short terms on the system we built. It's a classic 2-unit Lenovo server with Intel CPUs, lots of memory, filled up with Intel SSDs. We're using 2 NVMe boards in each server, running Windows Server 2016 with software-defined network and storage. We're using Hyper-V and Windows Azure Pack, and of course in time Windows Azure Stack. With this, we are ready to meet the demands for the next generation real scale-out data center. Thank you very much for listening and enjoy your time here at Atlanta.
So as mentioned, my name is Greg Kettman. I work for Lenovo. I am a product manager on the Azure Stack and S2D products. I'll also be talking about SQL Server and our performance and then give you an idea of the hardware. So as Philip discussed, there's a marriage between hardware and software. So those two have to come together in order to enable the solution. So we're going to give you the hardware side of that equation at this point in time. Now, I don't know about you guys, but at this point in time, I feel like we've been running a marathon. Does anybody else feel that way? So this is time for the final sprint. So here we go. So, and so we can all get ready for the party tonight. First thing I'm going to discuss is Storage Spaces Direct. We've heard a lot about it. Philip talked about it. With Storage Spaces Direct, I won't get too much into the details because I think you've had it by now. So hopefully everyone gets the idea. This is hyper-converged storage. This is storage in the node. That particular node then is able to use Hyper-V to serve up VMs to the environment. And that entire unit then is used, which supplies everything you need. Mirrored, it is contained typically then with Lenovo switches so that you put the whole solution together. In our reference architectures, we will include everything, not just the storage nodes, but we'll include the networking so that we can tie it all together. Now, one thing that's important about this, on the bottom of the slide, you see WSSD. This is a certified solution. So in order to be running S2D, you will need to run on certified hardware, okay? That will be inclusive of storage adapters. That will be inclusive of NICs. As Philip mentioned, there's a lot of capabilities that need to be in there, so it's the standard HCL. You're going to go out, you're going to look and make sure that the components you want to do, or you'll use the reference architecture that we've done. We will have a completely configured solution that you will be able to put together and use for your environment. With that in mind, then, this is our core unit. So this is the base unit. This one is shown with 12 forward-facing drives. There's an option also for 4 more on the back. As Philip mentioned, it is nice. There's 2 SAS boot drives on the back. They plug in the back, and they do not take away then from your available storage pool. So the way these are typically configured, well, I'll go to the 3 configuration screens. So we will have 3 t-shirt sizes in the S2D space coming out of the gate, okay? So at least this is our initial expectation on the offering. So the capacity optimized is similar to what we use in Azure Stack, which I'll get into in just a minute. You can look at the specs there. So that's a 2-tier environment. There will be a total of 14 drives in that. So you can see the 12 here. 4 of those then will be cache drives in the SSD. And then there's 8 spinning disks up front, 2 spinning disks in the back, and these are 3.5-inch disks. They can either be 4 terabyte or 6 terabyte. So simple math tells you that the capacity tier on this presents a raw 40 to 60 terabytes. Now, we also have other configurations. So for example, the balance configuration, next one down. The big difference there is we add a 3rd tier. So in this environment, we've added the 3rd tier of the NVMEs for additional performance. And then finally, performance optimized. Now the big difference here is that we moved away from the 3.5-inch form factor and we've moved into the 2.5-inch form factor. So we've increased the number of drives. We can fit 24 drives across the front of this. So 2.5-inch drives, less capacity, but we're going to have a lot more IOPS in this particular configuration. So that is the Lenovo S2D storage offering, as you'll be seeing it, and initially that will be in a reference architecture, pre-certified configurations, ready to go. Any questions on S2D? All right, so let's move forward then to Azure Stack. Azure Stack is Microsoft's Azure on-premise. So anyone that's used Azure today, how many people are using Azure? All right, so if you're used to that paradigm, you're used to this product, okay? The same user interface, the same paradigm is what's going to take place. Now the way to achieve that end goal is, and by the way, we have demos of this running in our booth, we have demos of this running in the Microsoft booth. So you can see this in a multi-node configuration, just like I'm describing here in both of those booths. And if you look at the user interface, it looks exactly like Microsoft Azure. The difference is going to be one says Azure, one says Azure Stack. But beyond that, there is very little difference. Now, we've pre-configured this solution. This is being co-engineered with Microsoft. The tie between software and hardware is very tight. It has exactly to do with what Philip was talking about. The protocols, the APIs, the need for the software to control the hardware so that you can go to a console and deploy the resources in a very, very seamless fashion. Now, we're building this. It looks just about exactly like S2D, because it's built on S2D. So as S2D is built, starts with 4 nodes. You can begin those 4 nodes, and that is the starting point. You must begin with at least 4 nodes. Those 4 nodes are configured exactly like that top S2D node that I had described a moment ago. So it has 14 drives that will be cache and capacity tiers, and then an additional 2 drives for boot. This is a completely pre-tested and validated solution, and it's an integrated solution. So at Microsoft Developer Conference, they announced that they will have 3 partners. Can't remember who the other 2 are, but Lenovo is certainly one of those. So with that in mind, Lenovo and Microsoft are working very closely together to bring this to you, and it's completely integrated. So what you will get is a turnkey solution. It's going to be completely integrated at Lenovo factories. We're going to take that unit, ship it to your premise, and then we will have services, specially trained, specially equipped services that will come on site. They will configure that device, and they will customize it to your environment. Your IP addresses, your Active Directory, anything it needs to tie into will be done so that your first experience with this is completely painless. Your first experience with this will be that console, the Azure Stack console, so you can start deploying resources. That simple, turnkey, ready to go. Now, Windows Server 2016 GA'd this October. I'm sorry, I'm still confused if it was GA'd at the beginning when they had the initial conversation or not, and they brought it forward 2 weeks or not. But certainly within 2 weeks, Windows Server 2016 will be here, and along with that comes S2D. Okay? So those are available for all intents and purposes now. Azure Stack, on the other hand, is available in the middle of next year. So we're still working forward towards this target. It is expected in mid-2017. Now it does scale up. So although the initial configuration will be 4 nodes, again, a minimum starting point, it will scale up to, you could go in 8-node increments. So 4 to 8 is really the sweet spot. So that is a fault domain. You will have up to, you can grow in 1-node increments up to 8 nodes. And then if you'd like to, you can combine fault domains so that we can grow beyond that. This system is managed by xClarity. So there are actually 2 elements to that. So there's one piece which is the hardware. So xClarity Administrator manages the hardware. I have a slide on it in just a moment, just to give you some of the capabilities of that. But it's what's managing the hardware. So the fundamental adding equipment, adding whatever you need to do to the hardware, firmware levels, et cetera, is done in xClarity. And then up above, you have the Azure Resource Manager. That's what pays attention to what's in the pool and deploys those resources. This is the configuration. I gave this to you just a moment ago, so it's the same. It's a little early to be talking about exactly what it will look like since it's 9 months out, but I do expect we'll probably ship in either a short rack or a tall rack, depending upon needs. At this point, though, it will definitely be 4 nodes growing to up to 8, and then we can combine groups of 8. If you need to start a second group of 8, if you want to go beyond 8 nodes, you'll have to start at 4 again and then keep building again. So any fault domain must begin at least 4 nodes. And it is factory integrated and services delivered. This is a little bit on our services, just to mention, as I've said, it is a services delivered option. So the only way to get this done, it will be included in this. So this entire Azure Stack solution, single part number. So you're going to order a part number, and it's going to come to you completely installed, configured, and delivered. So the services component is a required element. On top of that, though, that means you've got one part number for defect support, for problem diagnosis, wherever you want to be. 1-800-Lenovo, you call against one part number. You don't have to worry about the element of it. You don't have to worry about anything. Call single number, and we'll support the entire solution as a single solution. xClarity, which I mentioned before, is the low-level hardware manager. Sits at the bottom, discovers new equipment as you install it. So I mentioned 4 nodes up to 8 nodes for a fault domain. You want to add a node, xClarity is going to bring that node into the picture and give it to Azure Stack. Monitoring equipment for errors. Hard drive starts spinning up errors, starts throwing errors. We can monitor that. Hard failure, fan goes, whatever the case may be. The system, sure. It's going to depend. We're still working out the details on element to element, right? So it may depend on that. But in general, yes, this is a fully Lenovo supported. Expect a tech to come out. Okay? Again, though, some of that's we have to look through by through. So a fan, I don't know. A hard drive or a CPU certainly is going to require a tech. Okay? Hard drive, questionable. Question? Yes, so xClarity is our system administrator from Lenovo. And xClarity Administrator basically comes with the servers. There's also another xClarity product above that that can be purchased. This comes with the units. Yes. xClarity Administrator. Please? And I'm sorry, I should be repeating the questions back so everybody can hear it. So the question is, does it come with a rack? Yes, it does. So the xClarity, not xClarity, the Azure Stack solution comes completely. So there's a rack, there are PDUs, there are network switches on top, et cetera, the whole bit, and the nodes. To be determined. So we've got 9 months left to go. We are talking to hosting companies, so we are aware that there are requirements that are still evolving, and that's an excellent question. Oh, the question is, what if you're in a colo hosting facility that doesn't allow us to bring racks? So that's a great consideration. Thank you. We'll think about that. Go ahead, one more. I can. Are you asking about licensing in S2D? So S2D is not an integrated offering like Azure Stack. So Azure Stack, you're buying a single part number, and that single part number then falls under the support on that. As far as the virtual machines within Azure Stack that you're deploying, that licensing is a different issue, different conversation. In S Yep. S2D as it stands now is a reference architecture. So basically you're going to pull the information, it's going to be a pre-tested configuration, we're going to give you a bill of material, and then you're going to buy the components within the bill of material and assemble that. Yes, you can. Okay? Other questions? I did mention, by the way, and I didn't cover it on the chart, but it was discussed. So within Azure Stack, that does include switches. So those switches, in case anyone wants to know, there's a 1 gig maintenance switch, and then are redundant. So exactly like the middle diagram you saw on Philip's charts, there are redundant 10 gig switches, okay? So all the machine-to-machine, node-to-node connections are via 10 gig, and then the external facing connection is 40 gig. And if it did grow to more than one rack, those connections in a rack would be 40 gig as well. And they do support RDMA, et cetera, okay? xClarity, configuration, deployment, et cetera. Okay, so questions? SQL Server. So, sorry, just want to time check and see where I am. SQL Server. So we hold the performance records for SQL Server. We have pre-tested, pre-configured units for SQL Server. They're the fastest on the market and the most reliable on the market. And these aren't our statistics. Those wouldn't do much good. These are industry statistics, and I'll show you where they came from in just a moment. Number 1 in TPCH, number 1 in reliability, number 1 in customer sat. This is the same information, but with a little bit more information on it. But I think I'm going to go to the next slide, which does give those offerings. So these are our 4 predefined offerings that we have for SQL Server. Now you'll notice the first one is on a 3550, which happens to be a 1U unit, okay? Now the 1U unit and the standard right next to it, the 2U unit, same motherboard. So the only difference between those is the shell that it goes in, and obviously then the 2U unit has more capacity for storage. So that's the primary difference between those two boxes. They're both 2-socket machines, but the 2U, we can fit a lot more storage in it. So whereas the entry level is 6 terabytes, the standard unit will take 22 terabytes. And again, these are pre-configured, t-shirt sized, performance optimized units. Now our new units, they get even bigger. So we have the highly available at 60 terabytes, so the 2U back to back. So now we've got in a redundant clustered type configuration. And then finally the advanced. At 145 terabytes, This is on our 3850. So this is a 4-socket machine. Optimized for SQL Server. Okay? And by the way, if there are technical questions that exceed me, I do have our technical experts in the audience in front of me. So if you do have very technical questions, please ask them and we'll make sure we get them answered. I mentioned that we won the TPC benchmarks, and also there's two. So the bottom table is the, depending upon the types, correct? The query activity. So with that in mind though, please notice line 1, Lenovo, all right? And we won that, and I highlighted on the green box next to that, not only did we win for performance in the table by the benchmarks, okay? Not our test, independent lab test, number 1 in performance, number 1 on cost, okay? The little green in there is 89 cents per transaction. Cheapest on the list. So not only do you get the best performance, but it costs less. It's an important consideration. And as you go down the list then, we have other machines as well that also are on the list. So the top one, I can't even read it from here, sorry. You presume you can't either there. So the very top one is on an X3850, and then the line 5 is a 3950, okay? And then additionally, we have the other results down at the bottom. We also won that on a 3950. Those are the units as you see in the upper right-hand corner. So this is the TPC-E performance. So again, different read-write workload stream. This is the Lenovo, this is just, instead of the table where all the results are listed and highlighting where Lenovo fits in the list, this is the cherry picking of where Lenovo fit in each of these and the performance results thereof. And you'll notice that it's on a wide variety of our machines. So 3850, 3650, 3950. The 3650 was the 2U, the 3850 is a 4U, and the 3950 is an 8U. So, that was it on SQL Server. Any questions, particularly technical on SQL Server? You're off the hook, Vinay. That's a great idea, huh? All right, so I am going to just briefly discuss our product line then, just so you know what we're talking about. So we have 25 machines, number 1 in benchmarks. We're the first modular design, multiple generations. That's the 3850, 3950, shown closest to where that is. First and only 8-socket, 3950, 8-socket machine. And also SAP HANA. So anybody running SAP HANA? Over 50% of the marketplace is sold on Lenovo gear, and that performs extremely well. I mentioned that we're the highest reliable server. Don't take our word for it, please. These are results, industry, ITIC. We're down at the bottom there, because this is the other way around. This is number of faults. And you'll notice that next to us, what are we surrounded by? IBM Z series, mainframes, and IBM P series, power. The only Intel offering in that is Lenovo. And that's our performance. I mean, that's our reliability. Significantly better than the competition, something you should consider. Customer satisfaction, another huge consideration. You get it in, you install it, do you like it, do you not like it, etc. Lenovo, we're gaining. We're number 1 and gaining. Dell and HP are actually losing, okay? Again, not our results. These are independent results discussing the server platforms. So from there, I'm really going to go into our entire product portfolio. Don't worry, I'm not going to go through each one. You're pretty safe. But keep in mind, I did mention on the 3650, 3550, so 1 and 2U, 2 processor. Those are kind of the mainstream. And in particular, the 2U, 3650, that's what we're seeing for S2D and for Azure Stack. It's a workhorse. It's an excellent machine. We can load lots of storage into it. We can put lots of processor in it. 2 cores up to 36 cores, I believe. 2 sockets up to 36 cores, I believe. I think Intel tops at 18, right? 22? So 44. Over on the far left-hand side is the 4P8P, so 4 processor, 8 processor units. So those are stackable. Additionally, if you want or need, and we'll see where some of this goes, won't apply to Azure Stack. Azure Stack's 3650. But we'll also see some more movement in the more value, the Robo, the Office, the stand-up tower units. Those are in the lower left. And then, of course, we have Hyperscale. Hyperscale is available, and in addition to that, we have Flex Chassis, we have Blade. Yes? That I don't know. Someone? Did you hear that? So which are optimized for GPUs? And the answer was 3650 and next scale. Okay? This is a little bit more on our 2-socket servers, and then the next slide is a little bit more on our 3850, 3950. So though that information is available, I don't need to dig into that. So that is the conclusion of the hardware aspect. So with that in mind, any questions across anything except Philip's content, but anything on the Lenovo section, any questions?
Right now, we're using Reliant servers, and they have ILO. What is Lenovo's
Xclarity for the tool, and then what's our service processor? IMM.
Is there additional licensing for different features of that? Because with ILO, you have a basic license and an advanced license. Is it? Okay. IMM, all the advanced features are in there. The only features that are purchased
So just to repeat that, so IMM is the module that does that. Most of the features are in there and included. There is one additional feature that gets added, and it was remote presence. Okay? Any other questions? Yes? We certainly support nano servers, so I don't know the details. The question is, do we support for drivers in nano? So I think the easiest thing to do is if you could talk into the mic, Dave. Okay. So the question is in nano servers about driver injection, how to get the drivers into nano. So, David.
Yeah. So up until now for the nano server, all the drivers are in the nano itself, and you install it. The only one that's required at the moment is the network driver for nano. In this case, for example, if you deploy S2D, that would be the Melnox driver.
Thank you. Any other questions?